of the sample proportions of voters for presidential Pete will be between 44% and 50.5%. What's that one? What does that one have wrong with it? Because we already know it's false. 95% is not. Well, correct. Correct. Yeah, we can't say what proportion, okay, of sample proportions. We are not tabulating the p-hats that are in my p-hat interval. Good. Okay, so let's look at F. We are 95% confident that the sample proportion of voters in favor of Pete is contained in this interval. Okay, I'm 95% confident that your p-hat is contained in this interval here. That's what that's saying. So what do you say? Yeah, is it the same problem as above? I mean, the same thing? There is no reference to the likelihood or not, or whatever, how confident I am, another p-hat being in my p-hat interval. So again, this p-hat is an issue. And both of these are the same reason as part C. And both of these are the same reason as part C. All right, last one, E. I'm going to tell you, yes.
So if that's like the true proportion, then
okay, let me think. Okay, D would still be wrong because you don't have 95% of the true proportions. Okay, so D would still be wrong. C, if this procedure were repeated many times, then approximately 95%, it would have to say 95% of the 95% confidence intervals would contain the true. So that one's kind of mixed up too. This one, I'm 95% confident that the true proportion of both, yes, if F had said true, it'd been correct. The other C and D, I think, are all wrong. Okay, now, E is so close to being completely right. So close. There's one little thing of ambiguity in it that makes it wrong. So let's read it and see if you can't find that little component of ambiguity or vagueness that needs to be fixed. So here we go. If this procedure were repeated many times, right there, what's visualizing in your head? This procedure being repeated many times. You have many intervals. Okay. So, back to E. If this procedure were repeated many times, approximately 95% of the resulting intervals would capture the true population proportion of voters in favor of Pete. This is the part, I think okay, well the 44 to 50.5%, that's not needed. Okay, that's not what's wrong with this thing. What's wrong is the ambiguity here. So what would fix it? It says 95% of the resulting intervals. You're on the right track. They have to be, okay, remember this right here? 95% of the 95% confidence intervals. I can't have willy-nilly different intervals. I can't have 80% intervals and 99% intervals and 96% intervals. They have to all be the 95% intervals. Okay? That's the ambiguity that is wrong with E. This could be fixed if you say 95% of the resulting 95% confidence intervals. That would fix it. 95% of the resulting 95% confidence intervals are going to capture that true proportion. Okay, so very good. Now what I want to do is walk around and stamp you for parts 2 and part 3 while you are working on your warm-up. Okay, and then I'm going to go over chapter 3 homework if I have time. Okay, so on your homework part 3, first of all, let's kind of go over a few of these things. Here's the first page. I actually really liked the connection from problem 1 to problem 2. So let's talk about this more than just you getting the right answers, okay? So, number one was trying to make a connection of about New Zealand 16 to 20-year-olds, okay? But the deal is, it thought it could kind of get a baseline estimate with some American numbers. So it used this proportion from the American numbers to start off. And so then they said, we'll need about 385. Please be specific with the sample you're going to be taking it from, okay? They were taking it from 385 New Zealand 16 to 20-year-olds, okay? Be specific on the sample. Now, number two, look here what happened. Yes? No, they're wanting to make a inference to New Zealand 16 to 20-year-olds. So, because it's the New Zealand Drug and Alcohol Commission. So therefore, they're pulling from New Zealand 16 to 20 years. Okay, now look at number two. If you were collecting data and then you got and you were thinking a sample was going to work or a sample was going to be representative, look at this yellow part on number two. They believe that the cultures are different enough between the countries that American sample did not necessarily represent the New Zealand 16 to 20-year-olds. So therefore, using the p-hat of 0.2 is not reasonable because it's not a representative sample of data. So therefore, you go with p-hat being unknown and use 0.5. Look at what a difference it does in the size of sample you need to take to make sure you're going to have representative of the New Zealand 16 to 20-year-olds. It's actually 215 more New Zealand 16 to 20-year-olds. Okay. Multiple choice-wise, number 3 was D, 4 was B. 5 is another straightforward problem. You did not know p-hat, so you used the 0.5, and it was 1,295 TV viewers. Again, make sure you're specific in the sample you're pulling from. All right. Number 6 is not a huge issue. I know that if you're increasing your N, you know that the sample size will get smaller. So A and C are out. But the key is, how much smaller? Well, look here. If you're multiplying the sample size by 4, and that falls underneath the radical, then you are essentially square rooting the 4. So the square rooting of the 4 is going to reduce the standard deviation by square root of 4, which is 2. So that's why that comes out to be D. 7 is a straightforward solve for N. 8 is a problem that has to do with wording. I'm going to save that for a minute, see if we have time. Let's go on to, we'll come back to that. Number 9 is D. We will do number 8 together if we do it, if we have time. Let's look at the specifics you need to make sure you are doing for a panic model. Again, make sure that when you do list what this P value is, what you are estimating for is usually found in the paragraph. It is the proportion of all seniors. Remember, this has to be about the population of all seniors at State University who cheated during their college careers. And then on your assumptions, remember to write these words out. So the random was stated, the independent 150 was less than 10% of all seniors. It is large enough because 93 is how many were in favor. That's where that number comes from. Also, you don't have to write this, but here's where that came from. N times p-hat, which is 93 over 150. That's why that's 93. Okay? And then the ones who are not is 57. So the normal model applies. You have to name the test. These are 1 proportion Z intervals. Okay, this is one of like about 12 items that you're going to learn how to do. So the I is making the interval, which we come up here and we see it's 0.542 to 6.698. So in conclusion, I am 95% confident that the true proportion of seniors at State University that say they cheated on an exam or major paper is between 54.2% and 69.8%. Now, B is interesting because you are asked to be actually quite accurate. You are asked to be within a margin of error of only 1%. So that's going to be a pretty small interval, and you're supposed to be 95% confident. When you solve, look at what happens here. You need 9,051 students, senior students at State University. Do you see any potential problem with this and the conditions that have to happen? Independence is going to most certainly be violated. I do not think it's reasonable that 9,051 is going to be less than 10% of all senior students at State University. That means there's like 90,000 or more, more seniors at State University, which is twice the number of all students at UT. Okay, so pretty much, then what happens is you go back to the people that wanted this small of a margin of error and you say no can do. So you're either going to have to back off on this 1% or this 95% confidence because I'm not able to meet those needs. Okay? And then C is easy. That's just the 80%, of course, is smaller because your critical value is only 1.282. It's a smaller interval than your 95% interval. So let's go back to number 8 that you did not do. So let's do that one together. Here we go. This is about interpretation of margin of error and the wording. So I actually have seen a problem almost just like this on AP multiple choice. So I really like this one, and I want you to be able to understand what's going on here. All right. So a recent survey of 500 people report that 67%, so that's the p-hat you got, of American adults believe that high gasoline prices are caused by the greed of the oil companies. And so they give you a margin of error of 0.03, and then they wonder what that margin of error means. Okay? Let's knock off D and E right away because those are just like, duh. So D says, does the margin of error of 3% mean that 3% of people were not surveyed? Okay, that's like has nothing to do with what margin of error is. E says that the margin of error of 3% means that 3% of the time, the value obtained is going to be different from 67%. Okay, that's totally not what margin of error is. So, I have a picture for you to demonstrate the rest. This 67% means this 67% is the p-hat you got. You have a margin of error of 3%. So, yeah, your interval goes up to 70% and down to 64%. So, I want you to pretend that this was a 95% confidence interval. Then what can we say about our interval? We are what? 95% confident that what? Aww. Time's up. Okay, it's C there. But anyway. Okay, so let's go ahead and finish explaining this, even though I lost my last class. So we know that this is our interval. So I am 95% confident that the true answer is going to be between 64 and 70, okay? So I'm pretty confident that my interval will capture the true proportion of adults that think high prices are caused by greed of oil companies. Okay, so what happens is actually then, if I'm 95% confident that I'm going to capture this, that 67% has given me an interval that captures the true answer, then guess what? That means it's unlikely. There's only really a 5% chance that I would have gotten this p-hat if it's in there. So it's unlikely that I would have gotten this 67% unless the true value was between 64 to 70%. So that's why that has to be the answer. So since I'm 95% sure that it's in there, I would have only gotten a different p-hat if it was unlikely. Okay, now let's look real quick though why A and B are wrong. A says that no more than 70% of the population believes that yada yada yada. That's saying that it is not possible for the real answer to be out here above 70%. And absolutely it is. I mean, I am only 95% confident that I captured that answer Okay, so the real answer could be above 70%, which is also the reason why B is wrong. It says the actual parameter is between 64 and 70. Not definitely. I'm only 95% confident that the true proportion is between 64 and 70. So there's that. Do the warm-up for chapter 19 because we will quiz tomorrow.